Hello everyone, today we are presenting our project on environmental conservation in Binh Thuan Province, Vietnam. This is part of our COS10025 course and we are team F6. Binh Thuan Province, located on Vietnam's south central coast, is known for its beautiful beaches and marine ecosystems. With a population of about 1.2 million as of 2022, according to average estimate of the General Statistics Office of Vietnam. Its main industries are tourism, fishing, and agriculture, mainly planting dragon fruit. We've identified four key environmental challenges in the region. First, coastal pollution. This includes beach debris, marine litter, and oil spills. These issues not only mar the beauty of the coastline but also threaten marine life and local industries. Second, ecosystem degradation. We are seeing significant damage to coral reefs, declining water quality, and increasing impacts from climate change. These factors are putting stress on the delicate balance of marine and coastal ecosystems. Third, waste mismanagement. The province struggles with limited infrastructure for waste management, improper disposal practices, and inadequate recycling system. This leads to accumulation of waste in coastal areas and waterways. Finally, monitoring deficiencies. There's a lack of real-time environmental data and difficulty in tracking pollution sources. This makes it challenging to implement targeted solutions effectively. These interconnected issues have significant consequences for Binh Thuan's environment, economy, and quality of life. Our projects aim to address these challenges through innovative technological solutions and community engagement. In the following presentation, we'll explore each of these issues in more detail and propose our ideas for tackling them.
Hello, I would like to talk about my design idea, which is the trash tracking device using IoT technology. Instead of trying to solve the immediate issues, this device aims to provide more information about the trash flow in the nature, as well as data for the future analysis. So here's the design of the device. It will try to behave as close as possible to a piece of litter. This means that it will use materials often found in the waste, such as plastic bottles or wood blocks. We will have other components attached to this case: the plastic bottles, such as the antenna, the solar cell, the pallets, the processing unit. So the antenna, it will be used to connect the device with the GSM network. The solar cell will be used to provide the device with the renewable energy, and the pallets is there to balance the device, to stabilize the device when it is floating in the rivers. And finally, the processing unit is there to collect other data, the environmental data, and process it before sending it back to the scientist. So basically, this device will simulate the behavior of a trash piece in the nature. It will be strategically deployed across Binh Thuan's river and stream network. Here, like in this map, these regions serve as a critical pathway for the transportation of man-made debris from inland sources to coastal environment. By utilizing open source software and advanced hardware, our devices will aim to track the movement and accumulations of trash along these waterways before they come to the sea. So, and after we have tracked the trash flow in the seas and the rivers, we can give the data back to the scientists so that they will inform the users, the populations, as well as the government, so that the governments, they will devise campaigns and strategies, as well as raising awareness for the populations. So here are the benefits and the constraints of the device. So the first benefit is that it can track the trash movement in real time using the GSM technology. So that since it is real time, we can know the current situation much better than having old data. We also have data, so those data can be used for environmental analysis, since those data are about the pollution rate, the current water flow, and this data is not only beneficial for the scientists but for other future generations. we also have technology exposure for local people. So this technology exposure here means that the youngsters, they will be able to have experience with working with those devices, which will help them to cultivate the passion for technology in them. We also have long-term policy formations. So since we have lots of data from the environmental analysis, this will help the governments and the authorities to make new policies to control the pollution better. The devices are also affordable and non-invasive since the materials are reusable as well as biodegradable. For the constraints, there are some constraints. The first one being the digital literacy requirements. So these devices are very complex and require some maintenance as well as expertise. So there will be a need for proficient engineers. And finally, the initial funding can be costly. So that is all of my design idea. Thank you for listening.
Good morning, everyone. Today I'm excited to present our innovative solution for coastal cleanup in Bình Thuận, Ecoronist for coastal waste management. Diagram show our modern coastal waste management system using advanced technology like AI-equipped runners, robotic arm witness, waste bins, GPS and GIS, a central control hub, and live monitoring. AI camera runners detect and classify coastal waste using high-resolution cameras and AI algorithm, surveying the coastline to identify waste type and location. Once detected, data is relayed to robotic arm witness that gather the waste. The collected waste is transferred to bin for storage until processing or disposal. GPS and GIS track run and robot position, adding in precise waste location. A central control hub processes this data, offering real-time insight and updates. Second image shows the structure of a floating bronze. The light blue section has the bronze stay afloat, while the center of gravity and center of buoyancy ensure stable operation and flotation. The reference point is used for calibration during operations. A camera mounted on top detects waste, and propeller enable the bronze to move on the water surface. Additionally, robotic arms extend from the bronze to collect waste using net. Poetry Stay Abroad begins with waste detection and analysis. We use AI-driven cameras on bronzes to monitor the coastline in real time, a community reporting app for local to report waste with geo-tag photos, and stationary camera provides for continuous monitoring. In waste collection and eradication, we deploy robotic arms on bronzes to collect and store waste. Short-based robotic units guided by bronzes for efficient collection, and manual teams supported by bronzes for to waste removal. Finally, waste management and prevention involve real-time data transmission for seamless coordination, data-driven strategy to minimize new waste, and predictive analysis use GPS and GIS to forecast and prevent future waste accumulation. Finally, let's discuss the benefit, impact, and constraint of our solution. Our EcoROS project brings several significant benefits. Environmentally, it ensures efficient detection and collection of waste, leading to cleaner coastlines and healthier marine ecosystems. Economically, cleaner beaches attract more tourists, which in turn support local economies. Health-wise, by reducing coastal pollution, we decrease health risks associated with waste, promoting a safer environment for both residents and visitors. The impact of our solution are eco-noteworthy. It provides employment opportunity in bronze operation, maintenance, and data analysis, boosting local job markets. Additionally, the project raises community awareness about the importance of environmental conservation and encourages sustainable practices, fostering long-term environmental stewardship. However, we must also acknowledge the constraint. The initial investment and maintenance costs for the technology can be high, which might pose financial challenges. Moreover, the system requires reliable technology capable of operating in harsh coastal conditions. Despite these challenges, the potential benefits and positive impact of the EcoROS project make it a promising solution for coastal waste management.
Hello everyone, today I will introduce my design idea, an innovative solution designed to address the challenge of marine oil spill called oil spill collection robot. Our robot is equipped with GPS and mini camera to detect oil spill on the ocean surface. Once an oil spill is detected, our robot will move to the location and start the collection process. When oil and water enter the robot, the first step involves the use of specialized oil-eating bacteria, which help degrade the oil, reducing its volume. Furthermore, a boom inside the robot works to separate the oil from water. The clean water will then expel back into the ocean, while the collected oil is stored within the robot for safe disposal later. Moreover, the robot features a biosensor that can instantly track the pollutant source, ensuring precise and effective cleanup. Additionally, an acoustic wave device is used to expel marine animals from polluted area, protecting wildlife from harmful effects of the oil spill. Following the technologies and devices that we used in this design, first of all, we have the sensor, including oil detection sensor to identify presence and concentration of oil in water, covered with GPS and mini cameras. Then we have the control system, using microcontroller like Arduinos to process data from sensor and controls the robot action. Communication system, using wireless communication modules for remote monitoring and control. Then we have the power system, using battery packs with high capacity rechargeable batteries to power the robot component. And it will come with the mini solar panels to extend the robot operational time by harnessing solar energy. And that's why we have the collection and storage devices, including skimmer and mechanical devices that float on the water surface and collect oils, which is absorbing materials that absorb oil while repelling water using in construction with skimmer. And that's why we have the storage tanks to store the collected oil until it can be safely disposed of or processed. Next, our oil spill collection robot operates through three main stages, which is design and develop stage, deployment stage, and operational stage. In the first stage, design and development stage, we use a systematic engineering design approach. We start with the conceptual design, defining the robot objectives, and create initial sketches and models. Next, we move to prototyping, where we build and design a physics models. Finally, simulation and testing help us refine and design by using virtual environment and physical tests to ensure the robot meets all specifications. Going to deployment stage, here we focus on flight testing and calibration. The robot sensor and control system are carefully calibrated to ensure accurate detection and navigation. Through flight testing, we deploy the robot in control environment to assess its performance and make necessary adjustments. Training the robot machine learning algorithms with data from the test enhance its decision making and efficiency. Last one, operational stage, we advertise real-time monitoring and maintenance. We continuously monitor the robot function using on-board sensor and external control system to ensure effective oil spill detection and response. Regular maintenance and upgrade keep the robot in top condition, and we analyze operational data to improve future design employment. Besides, our oil spill collection robot offers a number of benefits, including quick detection and removal of oil spill, which minimizes environmental damage. It can work continuously without break and operate autonomously in danger or hard-to-reach areas, including continuous cleanup without risking human lives. The impact of the technology are significant that it adds in the rapid recovery of the ecosystem, reducing the economic impact on industry like fishing, tourism, and shipping, and helps protect public health by ensuring cleaner water. However, there are contrasts to consider. The initial cost for development, production, and deployment is high, and securing consistent funding and resources for operation and maintenance can be challenging. Additionally, hard conditions such as extreme weather and rough sea can limit the robot effectiveness.
My design aims to rejuvenate coral reef reliably using the blend of cutting-edge technologies by combining submersible drones, specialized coral blending tools, advanced environmental sensor, and user-friendly mobile app. This innovation approach addresses the critical issue facing coral ecosystem, such as habitat degradation, climate change impact, and biodiversity loss. Integrating these technology takes a significant step towards sustainable marine conservation and enhancing ecosystem resilience. There are three main hardware components. First is submersible drones equipped with high-resolution cameras and robotic arm. These autonomous underwater vehicles capture detailed image of reef condition and accurately place coral fragment on damaged reef, built to resist saltwater corrosion. They feature advanced batteries for extended operation and sensor for precise navigation, obstacle avoidance. Second component is coral blending tools, specialized equipment designed for reef habitation, featuring biodegradable blendings that support ergonomically, designed for use by divers or remotely operated vehicles, adaptable to various coral species and reef structures. The last component is environmental sensors. These sensors monitor key water parameters in real time, such as temperature, salinity, and pH level, providing accurate data crucial for assessing the health of coral ecosystem. Therefore, robust wireless communication capabilities for seamless data transmission, ensuring timely decision making in conservation efforts. There are also three main software components. First is data analysis software, handle and analyze large volumes of environmental data collected by the sensor. sensor, allowing researchers to extract actionable insight for effective risk management and restoration. Second is app development tools. Tools like Android Studio and Xcode are used to create a mobile app interface that facilitates user interaction with environmental data, promoting community involvement in conservation efforts. The last one is communication protocols, ensuring seamless data transfer between device and mobile app, optimizing data transmission efficiency and reliability, which is essential for timely information. Submersible drone conduct initial survey of damaged reefs to identify suitable location for coral blending. Coral blending tools deployed to these locations, guided by drone data and environmental sensor to precisely place coral fragment and optimize their survival and growth. Environmental sensor continuously monitor water quality parameters and feed real-time data into the mobile app. Mobile app provides stakeholders, including local community scientists and policymakers, access to environmental data, reef condition alert, and engagement opportunity in efficiency and effort. Enhanced risk restoration. The integration of advanced technology significantly improves the efficiency and effectiveness of coral reef restoration effort. Community engagement. The mobile web fosters community involvement, providing accessible information and promoting collective action in reef conservation and restoration. Scientific advancement enable comprehensive data gathering and analysis, advancing our understanding of coral reef ecosystem and informing strategic conservation planning.
Welcome to our presentations on Design Idea 5, a handheld vacuum cleaner. This innovative device incorporates a cyclone release catch for easy separations of the cyclone assembly. A cyclone assembly for efficient debris separations using centrifugal force. A bin assembly for primary dust collection. A suction mechanism to generate airflow, and a filtration system to capture fine particles, ensuring clean exhaust air. The vacuum functionality includes drawing in debris from through the nozzle, separating larger particles into the bin, trapping fine particles in a filtration system, expelling clean air, and allowing for easy bin disposal. Key benefits include efficient and thorough cleaning, powerful suction, an easy to empty dustbin, and a hygienic filtration system. Our design approach spans from user-centric design, technology integration, and sustainability focus in the conceptual stage to stimulation and modeling, rapid prototyping, and collaborative development in the development stage. And finally, to pilot testing, scalable production, and community engagement in implementation stage. For technology, we include high-capacity rechargeable lithium-ion batteries with integrated solar panel for eco-friendly charging and extended operation time, and an advanced multi-stage filtration system with HEPA filters to capture microplastics and other fine debris, featuring replaceable and washable filter for efficiency and sustainability. Despite challenge in cost and accessibility, we are committed to making this technology affordable and widely available. Thank you for hearing our presentation.
And that's the end of our project presentation. Thank you a lot for your attention. If you have any questions, please ask us in the 5-minute Q&A in class session.